All right, time to dive into a challenge I'm pretty sure you're familiar with. How do you keep your Android app from turning into a total monster of a code base as you keep adding stuff to it?
Yeah, it's classic.
Right. So today, we're going to do a deep dive into Android app modularization to try and tame that beast. We're working from this guide you shared some excerpts from. And trust me, this isn't just another one of those developer buzzwords.
No, it's definitely much more than that.
Okay, so picture this. Your app is blowing up, downloads are off the charts, users are loving it, but meanwhile, behind the scenes, it feels like every time you add a new feature or fix a bug, it's like you're just adding more duct tape to like a rickety old spaceship.
Yeah, I've been there.
And this guide actually calls this out, the growing code base problem. Have you ever run into that?
Oh, absolutely. It's that awful feeling when you realize that even the smallest change you make to the code could end up breaking things in a totally different part of the app. It can get to the point where it feels like you're just like one small change away from the whole thing falling apart. It's just not a sustainable way to build software.
Totally. So how does modularization help us escape that nightmare?
Well, at its core, modularization is about taking that big, tangled mess of code and breaking it down into smaller, more manageable, and independent modules.
So kind of like chapters in a book.
Even better, think of them more like building blocks like Legos or something. Each module has a specific purpose, and you can put them together in different ways to build different parts of your app, or even totally different apps.
Okay, I think I see where you're going with this. So instead of one massive, monolithic code base, we're aiming for a bunch of these more manageable modules. But why bother? Like, what's the real payoff here?
Well, just imagine that successful app we were talking about, the one that's struggling under its own weight. Let's say it's like a social media app, and it's got all these messaging features. With a modular approach, you could have one module that handles everything to do with the chat, another module just for the user profile, and so on.
Okay, makes sense.
So then if you need to make some kind of a change to how the messaging works, you could do that without having to worry about accidentally breaking something in the user profile section, right?
I'm starting to see the light here. Less risk, more control. I liked it. But it's got to be more than just dividing things up, right? These modules still need to work together.
Absolutely.
Yeah.
And that's where the true skill of modularization comes into play. You've really got to think through the design of these modules and how they'll communicate so they can work together without stepping on each other's toes, so to speak.
So it's kind of like a dance almost. You need the right partners, the right moves, and a whole lot of coordination for it to all come together.
Precisely.
And when it works, it's beautiful. This is really making sense to me now, seeing the app as this like collection of well-defined modules. But our guide goes beyond just, telling us what modularization is. It really digs into the why, like, oh, what are the actual benefits we get from putting in the work to go modular? What are some of those big wins?
Well, one of the most immediate benefits is actually something you just mentioned, reducing risk. Think about what it's like to test a monolithic app. Even small changes can mean you have to test the entire code base just to be safe.
Yeah, no one wants to do that.
Right. It's like you wouldn't want to bake a whole new cake from scratch just because you might have burnt the frosting a little bit on the first try.
I can definitely relate to that analogy. Haha.
But with modularization, if you make a change inside a module, you often only need to test that specific module. No more baking anxieties every time you make a little tweak.
That's a huge win right there. So less time spent testing, less risk of introducing new bugs, and just like an overall improvement to developer quality of life. Okay, I'm sold.
And that's really just scratching the surface. The guide also talks about this idea of strict visibility control, which, yeah, sounds kind of formal.
Yeah, break that down a bit.
Basically, it means that in a modular app, you have a lot more control over what parts of your code base can actually see and talk to other parts of the code. So you can use access modifiers like public, private, or internal in Kotlin to be really specific about what's exposed to other modules.
So it's all about setting up those clear boundaries between modules, right?
Yeah.
Like, my user profile module has no business knowing how the chat module works internally, so they shouldn't be able to mess with each other.
Exactly. That kind of separation between modules makes your code a lot more robust, easier to understand, and way less likely to result in those, wait, why did this break moments.
It's like each module has its own little workspace, and there are very clear rules about who's allowed to come in and touch what. And as we all know, less mess generally means fewer bugs. This is great. But I have to imagine there are some potential downsides too, right? This guide seems really balanced, so it must talk about those as well.
Yeah, for sure. Modularization isn't like a magical solution to every problem. In fact, the guide dedicates a whole section to what it calls common pitfalls, and going too extreme in either direction is definitely one of them.
Okay, so Goldilocks, right? Not too big, not too small. What's the just right when it comes to modules?
Yeah, exactly. If you have a ton of tiny, tiny modules, you can actually end up with a different kind of monster on your hands.
Hmm.
This super complex code base that becomes a total organizational nightmare to manage. But on the other hand, if you only have a handful of really big modules, then you're basically not getting any of the benefits of modularization in the first place.
Right, because then you are basically right back where you started, just with bigger pieces. So finding that balance is key. And I'm guessing the right balance is going to be different for every app, huh?
Absolutely. One of the most important points this guide makes is asking the question like, is modularization even the right approach for my situation? It's something you really need to consider, especially for smaller, simpler apps where it might be overkill to introduce all this complexity.
Yeah, it's like any tool in our toolbox, it can be really powerful, but it's not always the right one for the job. Speaking of tools, I really like how the guide dives into some common patterns that we can follow to modularize our apps effectively. And there's this one idea, low coupling, high cohesion, that really stood out to me.
It's a crucial concept. Imagine it like this.
Okay, so we were getting into low coupling, high cohesion. It sounds a bit mystical, like some kind of software development Zen koan or something.
You're not wrong, but it's really about finding that balance between having modules that are independent but also able to work together in harmony.
Right, right. So low coupling, that's all about making sure our modules aren't too dependent on each other. Right.
Exactly. Think about a well-planned city, right? Yeah. You've got different areas, residential, commercial, industrial, each with its own specific purpose. They're all connected, though, by roads and infrastructure so people can get around and things can function without it being total chaos. In our apps, low coupling means those modules interact through clear, well-defined interfaces instead of directly messing around with each other's code.
Okay, so clear boundaries and communication channels are key. What about high cohesion then?
So high cohesion is more about what's going on inside each module. Everything within a module should belong together, kind of like a well-organized toolbox. You wouldn't keep your screwdrivers all mixed in with your wrenches, right?
No way. That would make it so much harder to find what you need.
Exactly. It'd be a mess. In our apps, high cohesion means grouping similar code together within the same module. It keeps things tidy, focused, and easy to work with.
Got it. So a cohesive module knows its job and sticks to it. That makes sense. I'm really starting to see how elegant this whole modular approach is. But we've been talking about modules as these separate units. How do they actually work together in a real app?
That's where a really cool principle called dependency inversion comes into play.
Ooh, that sounds a little intimidating. Can you break that down?
Sure. Remember our social media app example. Say our chat module needs to store all those message history. Instead of the chat module dictating how that data should be stored, like whether it goes in a local database or up on a server somewhere, we can use dependency inversion.
So the chat module doesn't need to know about those specifics. It just says like, hey, I need to save this stuff.
Exactly. It defines a kind of contract or an abstraction for what it needs. In this case, it would be, I need a way to save and retrieve messages, but it doesn't care about the actual details of how that happens.
Okay, I think I'm following. So where does the actual saving and loading happen then?
That's where concrete implementation enters the scene. So some other module, let's say a data storage module, would handle all those gritty details about interacting with the database or server. The cool part is, our chat module is totally oblivious to all that.
So it's like ordering takeout. I don't need to know all the steps to make a perfect pizza. I just need to know I want extra cheese.
Perfect analogy. And just like with our pizza delivery, there's got to be someone to connect that order to the actual kitchen, right? That's what dependency injection does in our apps. It usually happens at the app module level. Think of it like the project manager saying, okay, chat module, you need someone to handle data storage module, you're up.
I love it. It's like all these pieces of the puzzle are finally clicking into place. Independent modules with clear contracts, and then dependency injection comes in to wire everything up correctly when the app is running.
And the best part is that you can swap out those concrete implementations whenever you need to without affecting any of the other modules. Like if you need to switch from a local database to something cloud-based, no problem. Just swap out the implementation. Our chat module won't even notice.
This is seriously cool stuff. Talk about keeping your code flexible and ready for anything. This has been a fantastic deep dive. We've covered a ton about Android app modularization, from the why to the what to the how, and even those potential bumps in the road to look out for.
It's a powerful approach.
It really is. And even though we've gone way beyond just the buzzwords, getting into the nitty-gritty details of things like dependency inversion and dependency injection, we've really just scratched the surface today.
There's always more to explore.
Exactly.
Right.
But now you've got the knowledge to have more informed conversations with your team, to make better architectural decisions, and ultimately to build apps that are as adaptable and resilient as the users who rely on them every day. And that's what it's all about, right?
Absolutely.
Awesome. Well, until next time, happy coding, everyone.